Now a word from this week's sponsor, Onshape. Onshape is the only cloud-native product development platform featuring professional-grade CAD and data management. With Onshape, you no longer need an expensive workstation. All of the heavy lifting is done in the cloud. Things like rendering and creating large assemblies can be done on inexpensive devices. Onshape is a professional tool like SolidWorks. It was actually created by the same founders as SolidWorks. I have used Onshape and it feels just like SolidWorks with all the same commands. So if you're a current SolidWorks user, it's a very easy transition. I highly recommend all the engineers and product developers listening to consider Onshape for their business. You can try it for free at onshape.pro/engineering entrepreneur podcast or click the link in the description.
Hello, everyone. Welcome back to the Engineering Entrepreneur Podcast, episode 125. Seems like a good celebration number, a quarter of the way to the 200. This is your host, Scott Tarsi, and I run CADdesignhelp.com. Please go to my website, sign up on the pop-up, or just go to subscribe, and then you'll get emails each time there's a blog post or a podcast episode. Check out my online course, The Engineeringpreneur. There's a link right on my website for that. It'll help out you engineers who think about making the jump to entrepreneurship. I wrote a whole course on how I did it. And leave me a review on iTunes if you could. It'd be great. All right, so our guest this week is Daniel Shaddock, and he is the CEO of liquidinstruments, which is a pretty high-tech instrument measurement device company. I don't know how else to say it. We talked in the intro a little bit about how some of the equipment is being used by NASA up in space, some pretty high-tech stuff. So I'm going to let him kind of fill it in because I don't want to botch the technical side of it, and then we'll go from there.
Hey, Scott. Thanks for having me on today. Yeah, so I'm the CEO of Liquid Instruments, as you said. I was also a professor in physics at the Australian National University here in Canberra, so hopefully everyone can understand my accent. And before that, I worked at the Jet Propulsion Lab in Pasadena, one of the NASA centers in California, working on scientific instrumentation and developing new ways of really sort of precision measurement systems, work a lot with lasers, a lot with electronics, and really trying to push the state of the art in measurement technology for a whole bunch of different applications.
I have a little bit of experience with this in different instrumentation where when I worked at like some bigger companies, we had to run different tests, but I think it's a lot lower tech kind of stuff than what you're doing.
Yeah, so I think a lot of engineers would have used a lot of this equipment either in their undergraduate degrees, where you should have been exposed to things like oscilloscopes and waveform generators and maybe spectrum analyzers.
That's exactly what I was thinking. Yeah, that's exactly what I was thinking of. So maybe because, I would think that a lot of my listeners would have had, being engineers of different types would have had that kind of level. But obviously you went to do a PhD and went way more advanced. So maybe tell us what is different about like what you guys are doing compared to like that kind of stuff.
Yeah, so in terms of the instrumentation, so our background was very focused on a particular goal, and that was to detect gravitational waves, which is something that Einstein predicted more than 100 years ago now, that these waves should be emanated when black holes collide or supernovae go off. So it was something that had been hypothesized and theorized for a long time, but it was a very small effect, so really, really difficult to detect these things. So the size of the effect, what it does is it stretches space, and a super strong gravitational wave, if it passed between the Earth and the Sun, would move them closer together or farther apart by about the diameter of a hydrogen atom over that distance. So it's a really, really tiny effect. And for a long time, people didn't think it was possible, but it was, and it's being detected now. And I was very, very privileged to be part of the large international team that worked on this for many decades and ultimately detected them, and which has now been awarded the Nobel Prize in Physics a few years back. So yeah, that was a great experience, and it was a real goal that pushed measurement technology and instrumentation forward in so many areas because it had such challenging requirements. Where Liquid Instruments comes in is we started working on a way to build this detector in space, and that has a lot of challenges. It's the most complicated measurement device ever built. It was 4 kilometers long, a couple miles long, and there's one in Louisiana, one in Washington State, and figuring out how to put that up into space is a big challenge. So it made us look at new technologies and new approaches for how to do that, which is what led us to the software-defined instrumentation that Liquid Instruments really is built around. I guess the simplest way to think about that is it's about taking the complexity of the physical world and trying to push it into digital signal processing that happens on a very, very high-performance computer chip, in our case, an FPGA, which many of your listeners will be familiar with as well. So that's that's the spark of that realization that this is an interesting, powerful, and flexible way to do these measurements. Really kind of was the seed for starting Liquid Instruments after we delivered the technology for the NASA mission that it's now flying on.
Oh, very cool. Do you have maybe we could understand better if you had a example of something that you were measuring on the spaceship and how it works with your guys' technology?
So the system's flying on a mission called the Grace Follow-On mission, and this is unlike it's also measuring gravity effects, but it's not measuring gravitational waves. It's actually a climate observation mission. So its job is to map the motion of water around the Earth's surface by measuring how gravity changes from satellites in orbit. And the way you measure gravity is you measure how it affects objects. And so there's two satellites in Grace, and they're moving around in orbit in a pretty low orbit, couple of hundred kilometers apart, and you're trying to measure the changes in their separation to a tiny level. So around about a nanometer is what we're trying to do, over 200 kilometers. Apologies for the metric system, but yeah, that's all. It's been too long since I lived in the US and can convert units on the fly. That sort of sensitive measurement, we use a laser interferometer. So there's lasers shooting between these spacecraft, and so trying to measure changes in separation at the nanometer level while things are moving at thousands of kilometers an hour. It's pretty challenging.
Crazy that's even possible.
Yeah, it is. Yeah,
wow.
I think about it. It's like measuring if Sydney got closer to my city, Canberra, which is a 3-hour drive away, by the diameter of a red blood cell. That's sort of the difference in scale that we're looking at. And
yeah, I mean that's no person on their own accord could ever tell the difference. It's just such a small amount. Yeah. But I guess that's what you're talking about, these gravitational waves. That's the scale of it, right? It's just tiny change.
And so the way it works is you get these optical signals, which are very, very sensitive, but then you've got to figure out how to process those. And often they have some really tough requirements. They're real-time processing because there's a lot of data coming in. You've got to pick out tiny changes in voltages. And often there's a very large dynamic range to your measurement as well, because things are moving around and being buffeted around by various effects. So they're really challenging measurement. And it turned out that this FPGA approach, where we could constantly tweak, refine, and increase the sophistication of the way that we process those signals, was a massive advantage. The other advantage is that it's unlike if we did all this inside of hardware, there's a lot of other optical techniques you'd use. The digital signal processing, it doesn't degrade with time. It doesn't get dirty like mirrors get dirty. It doesn't age and get old. So it sort of is quite reliable. And the final advantage is that we can change it afterwards. If we messed up, rather than having to send an astronaut up to switch out the hardware, the great thing about FPGAs is you can think about it like an SD card, where the design of the chip is defined by a bit stream we give to it. And that bit stream, we can send up a new bit stream, completely rewire these chips in a fraction of a second, much like writing over your photos in an SD card, and you can implement an entirely new algorithm and change that on the fly. So it's a really useful, very robust, very powerful technology. And where Liquid Instruments comes in is that after we shipped off all the technology and we were pretty much done with the mission, we realized that those same attributes are really, really useful in a lot of other areas. So test and measurement equipment, there's around $25 billion of it sold around the world every single year. And it really underpins a lot of huge technology areas, trillions of dollars of development effort in aerospace and defense, in semiconductor, in telecommunications, automotive increasingly, and of course, the energy transition. They all use huge amounts of this sort of test equipment. And we figured, maybe there's a play here. Maybe we can offer something new if we share this with our colleagues to start with, and then get it out into the wider world, and that's really how it's worked. So, is
your only market really maybe I guess NASA and SpaceX, or are there other more on planet Earth companies that?
Yeah, we do sell some stuff to NASA, but nothing that goes into space. So it's really we started off it was a fun time at the beginning of the company, because really the concept was, if somebody made this product, I would use it. I'd probably buy 10 of them. Maybe there are lots of people like me, and that's sort of how we got started. And that's a great way to get started, because you're designing for yourself as a user, and a user who knows and cares about how that product works. And so you put a lot of love into it. You really understand a lot of the pain points when you're designing for yourself. And that turned out to be a great way to get our first product out, which is called Moku Lab. And it's this one device that initially replaced 3 different devices. It had an oscilloscope, a spectrum analyzer, and a waveform generator inside. But then through software updates over time, now it has PID controller and a lock-in amplifier and an arbitrary waveform generator, all these other things. So now it actually has 12 instruments inside.
Who would your customer be for that? There's a lot of stuff in there that you use for a lot of different purposes.
That's one of the big challenges that we have is we have such a diverse customer base. So we have probably more than 1,000 different applications people would use our stuff for. We started selling off to mostly to university R&D, where they had really high-end requirements for the specifications. Then we moved more into the industrial tech space. So a lot of our customers include, all of the big tech companies we've sold to in the last month alone. So there's a lot of appetite for this sort of equipment. Our sweet spot just tends to be people who are working in some sort of photonicsy area. So whether it be silicon photonics in the semiconductor industry or LiDAR in the automotive industry or coherent beam combination in aerospace and defense, there's a lot of those sort of applications because of our background in working with these sort of photonics type things. But really the diversity has been a big challenge. I'm sure you've heard of this sort of crossing the chasm approach that for startups to break out of their early adopter demographic and really kind of get into these larger industries. And the challenge for us is that the one of the big value propositions of our product is it is so versatile. It really does support so many thousands of different applications. So there's one of our customers was using it to measure. They built a system that would measure the degradation of paint in the Sistine Chapel. Another one of our users is
in the world. I guess is it almost like carbon dating with that?
Yeah, it's driving a complex laser system. So we don't provide the laser stuff, but then all of the driving of that laser, all the signal processing of those signals coming back to do the complex modulation, demodulation techniques they use for the spectroscopy, that's all done on our system because of the flexibility and the power. Yeah, another guy is using it to develop an ultrasound system that will measure the effectiveness of breast cancer drug delivery to see how that's being absorbed by tissues in the body. And then, of course, we have a lot of aerospace and defense users who really just need the highest performance to push their technologies forward and pass on to their customers. So a lot of automated testing stuff. Manufacturing is another big area where a lot of this equipment is used. So it really is the foundation technology that we use to build technologies.
Any more examples you want to give of different things that your product has been used for?
Yeah, so maybe, one of the things I think is interesting about our product and probably what gave us a bit of a smoother path is the way, so I see a lot of people who are sort of in my position as a professor maybe at a university doing some sort of cutting edge science and trying to commercialize that science is really quite challenging. And there's a lot of different steps to get it from the lab into the real world. And I think one of the things that really helped us in that path was we didn't really commercialize our science. Like we don't sell to do anything to do with gravitational waves. The reason that we developed this technology, really what we're selling is the tools that we had developed for ourselves to use. And because it's the commercialization of a cutting edge tool, that tool was already in use. It's already, very robust. It's well understood. A lot of the properties you need for space flight are also, something that's reliable, something that's robust, something that's high performance. There are also big advantages in the commercial space. And so that was a huge advantage, I think, that really helped us shorten the path to impact, where we could start the company, launch a product a year later, and then already have it helping customers do what they need to do. So I think that's a piece of advice I'd give to people who are considering, this commercialization path is that, often things take longer than you expect to commercialize, particularly if you're doing any cutting edge hardware. And finding ways that you can build that into other systems and use the parts that are operational has been a really successful strategy for us and really helped us along the way. Whereas if we really tried to commercialize some of the scientific outcomes, I think it would have been a lot longer journey to get to impact.
I think a lot of engineering types that create something, they have a lot of trouble, I myself included, with the marketing side, in the business case side, because so there might be a lot of value behind it, communicating that and getting that to the buyer so that they see what's in it for them. That can be real. Sounds like you pulled that off pretty well, but a lot of people struggle with that.
Yeah, and it's something we've had a lot of help for. So I think the other piece of advice that I think is valuable is that to seek advice widely, but you want to weight that advice based on the experience of the person that's giving to you. It's great to have a network of like-minded people who are at the same stage as you, but it's also great to talk to people who are who are a little bit farther along and maybe have made a few mistakes themselves. So yeah, it's great to learn from your own mistakes, but it's even better to learn from the mistakes of others. I find it's much more satisfying and, often leads to better outcomes. The other part of our product is that we've found uses in areas we didn't expect. So so the Moku Lab is a $10,000 device. It's, a pretty high-end piece of kit in terms of performance. And what we noticed is that it was actually finding its way into university systems and university education, which it was never really designed to do. It seems to be far too expensive for that. But it comes to the other part of the product that we rethought, rather than just focusing on the performance and the features of the product, was really trying to look at other areas of tech and borrowing the best ideas and bringing it to test and measurement. And one of the main areas I thought that test was really suffering from is that an oscilloscope today looks very similar to an oscilloscope that people used in college 30 years ago. And while that's reassuring to some, there's a lot of stuff that's happened in the world about how to use, how we interact with technology, how technology is designed for the user experience that deserves to be brought to this area. This is an important area, especially education for engineers. I think engineers and scientists can help solve some of the world's biggest problems. And we need to do a better job at making sure that we keep everybody in that pipeline and give them a great experience in the education space. So we saw that our device, this too expensive to be used in education device, was actually used in around about 30 universities for teaching in undergraduate education. And so we thought, well, one of the big advantages of this software-defined instrumentation is we can build much cheaper hardware, but we can bring all of the great stuff to that hardware, all of the great features, all the great UI that we developed for the professional markets, and bring it to education. And so that was something we launched last year, Moku Go, which now is a sub $1,000 piece of kit that has all the stuff that an undergraduate would need and more than they have access to today to do an entire undergraduate degree. And it all fits in a backpack because of the benefits of size, weight, and power of pushing all this complexity into this instrument on chip design that we have. So yeah, so that's something that's been an unexpected path that we've taken, but it's something that's very satisfying now that we have thousands of Moku Go's in more than 100 universities around the world that are being used to teach the next generation of engineers, and something I find very satisfying that we've been able to make a contribution and make those tools more accessible for students that otherwise wouldn't have access to them.
So did you have it's more than just you in this company, right? You've got a team because, there's a lot of different parts of the business here that would be tough to do all on your own.
Exactly. So we had a massive founding team. We had actually 12 founders of the company, if you can believe it, which is a big number. But it was basically, a lot of them were my graduate students or postdocs that I needed to, do the hard stuff. And a lot of them are still around today. So we're 8 years old now as a company, and we've grown to 60 employees. We have folks in 4 different countries, and we sell in more than 40 countries now, localized into all the different languages. One of the nice things about Canberra, it's a very multicultural place. And so in our own team, we were able to find folks who had moved here from other countries who could do the translations for us, which was great. And it's definitely been a massive team effort to get to this point. And we're growing pretty quickly. So we just raised a Series B fundraising round of just over 30 million. And now we're in a bit of a hiring spree for the next phase of growth. I think the potential is here to be, $1 billion revenue company in the next decade. And so far, all of the feedback we're getting from our users is that, either the first thing people think when they see this is, oh my God, it's too good to be true. It's got to be a scam. and it really isn't. And so, I think some technologies, the solution is just feels right and everything clicks. And I think we're very lucky that we've stumbled upon this software-defined instrumentation as a solution to a lot of the problems in tests that up until now people didn't even realize were problems.
Very cool. Well, hey, we need to get towards wrapping up, but the last 2 questions I'd like to ask is, what is your number one tip for the audience?
Yeah, so I think for entrepreneurs out there who are thinking about doing something or started to do something, so things will always take longer than you expect, but don't lose heart. And it's good to be aggressive and to set aggressive goals, and don't be disappointed if you don't always achieve them. I think you're better to set a super aggressive goal and miss it by 20% rather than set something that you think is achievable and hit it at the 100% level. So really think big and be aggressive. And I guess the other thing is every startup is different. And there's going to be a lot of people who give you advice based on their own personal experiences. And those personal experiences are largely unique. So you should listen, but your startup or your project is probably not the same as those. And it's really important that you figure out what is the most important thing for you and what is the most important thing for your product or your users, and focus on that. And that will change over time. So it's what's important today is going to be different from what's important tomorrow. And if you can focus on the important stuff at the right time, it will put you in the best position to be successful.
That's good advice. Yeah. I mean, a lot of people have advice for you, and it's fine to listen, but what works for you what works for them may not work for you. So, I always like to say, try some things, and if it doesn't work, pivot and try something else.
Yeah. Yeah, exactly.
Cool. And Daniel, if people want to learn more and get in contact with you, what's the best way?
Yeah, so you can reach out to info@liquidinstruments.com, and any questions will get routed through to me. Check out our website if you're interested in our products. I think a lot of engineers would love to have a Moku Go sitting in their garage somewhere for playing around with things. It's a great way. You can download the software for free and play around with the software just to see in a demo mode. So yeah, I'd encourage people to check out that at liquidinstruments.com. And yeah, love to hear any experiences of people who are either using our products and have feedback or have measurement challenges that they think that our technology could help with. We're pretty good phase now where we're all set up, and we're now taking requests for the next instruments that we release. So we'd love to hear from your listeners.
Very cool. All right, Dan. Well, thanks for your time today. It was very interesting, the company that you created, and enjoyed it.
Thanks, Scott. Great to talk to you.
Cool.
Now a word from this week's sponsor, Onshape. Onshape is the only cloud-native product development platform featuring professional-grade CAD and data management. With Onshape, you no longer need an expensive workstation. All of the heavy lifting is done in the cloud. Things like rendering and creating large assemblies can be done on inexpensive devices. Onshape is a professional tool like SolidWorks. It was actually created by the same founders as SolidWorks. I have used Onshape, and it feels just like SolidWorks with all the same commands. So if you're a current SolidWorks user, it's a very easy transition. I highly recommend all the engineers and product developers listening to consider Onshape for their business. You can try it for free at onshape.pro/engineering entrepreneur podcast, or click the link in the description.